An interesting philosophical question. Is your eye like a camera? Or is a camera like your eye? Which one? I mean, optically, it's the same thing. It's the same thing. But this has been an interesting philosophical debate. Are we machines? Or are machines like us? Okay? I don't know. But ultimately, I can say this. Doggone it, this optical system of your eye is exactly the same as the optical system of a camera. There's a lens in front. It focuses an image on the retina. Okay? That's ultimately what we're looking at here. Typically, when I solve problems like this is like the full structure that we have. I don't draw that full structure out every time. This is what I draw. That's your eye in this class. There's a lens in front. Oh, sure, it consists of like lens, cornea, all that kind of stuff. We don't care. We're simplifying the biology. This is a simple imaging system, works like a single lens, and it focuses an image on the back of the eye. And so you get something that looks like this. Let's take a look at this. This is the relationship for your eye and for a camera. 1 over f is equal to 1 over s plus 1 over s prime. When you're focusing a camera, the focal length of the lens is fixed. And the way you focus it, to make it focus on things at different values of s, is you change values of s prime. You change the distance of the lens from the screen. And if you watch digital camera, you might have one where you can actually see it doing that. Here's one that's more obvious. This is a really old school camera. And this is one where you actually took the image on a piece of film. And I wanted the image on the piece of film to be big, and so you had a big value of s prime, so it stuck out in front. And if you've ever seen like the seriously old school ones where like the people have the hood over their head, you've seen these in the movies, the stick's way out in front. Why? Because they used to develop the film directly. They didn't get a negative and make a picture out of that. It was the piece of film in the camera that got exposed. And so as big as the image was, that was how big your picture was. Okay? You didn't have the opportunity to magnify it. So if you want a big picture, you need a big value of s prime. This camera works like that. And here's my viewfinder. Right here. I just look through it and I see where the crosshairs go. Okay, so how do I know that it's in focus? I can't see the image. Here's what I do. Right over here there's a little scale. And the scale is distance. And it says if I'm focusing on something that's 1 foot away, I put it right here. Small distance, big value of s prime. Now, if I want to focus on something which is farther away, s gets bigger. What happens to s prime? S prime gets smaller. And so I can do that. This is focusing on something 10 feet away. And so I just change the distance here. Now, wouldn't it be sweet? Wouldn't it be sweet if your eyes worked like this? But it doesn't work that way. Typically, what happens is this. You focus on objects at different distances by changing the focal length of the lens. You change the focal length of the lens. We use this basic equation right here. The distance of things you want to look at vary, and so as a consequence, you can't vary this. You have to vary the focal length of the lens. You change the power of your optical system. You change the power of your optical system. Actually, you do this. This is kind of how it looks. In your eye, the lens is actually made out of flexible materials. When your muscles in your eye are relaxed, the lens is stretched out into kind of a flatter shape by these ligaments. Then you have muscles. When the muscles contract, these ligaments go slack, the lens gets chubbier, it gets rounder, it has a shorter focal length, it has a higher power, okay? And that allows you to focus on things which are closer. And so you're going to accommodate your vision to focus on different objects by changing the shape of the lens in your eye. And to focus on close objects, you're going to make the power higher, you're going to make the lens fatter, like this, power higher, and then you can focus on closer things. I'm going to do an approximation now, and we're going to do this approximation. In your eye, this distance from the lens to the retina is fixed, this number right here. For a typical person, it's about like this much. It's about 1.7 centimeters, 0.017 meters. By the way, too, in the book, it says it's like 2.4 centimeters. There's a distance between difference between an actual length and like an effective length, and it has to do with the fact that your eye is filled not with air, but your eye is filled with goo, okay? And so you can change that. But I'm going to approximate, it's this long, and then it gives me this. 1 over s prime is about 60. And actually, that's right. In this equation, 1 over s prime is about equal to 60. So I'm going to take this equation, and when I'm working with your eye, it turns into this. 1 over s is equal to 60 plus 1 over s. Now, that's an approximation. But here's the thing. That 60, that value is going to cancel in every calculation that we do. You could assume that this value was 600,000 if you wanted to. You could assume it was pi, and it would go away. But we're just going to use it as a placeholder. And the ultimate thing is this number, s prime, does not change. And so we're just going to call it 60. Then, for you to be able to focus on objects at different distances, different values of s, you have to change the focal length of your eye. You have to change 1 over f, which is the power of the lens in your eye.